We are starting our probability unit. Our probability unit is important because it's going to help us lead to a further ability to be able to analyze statistics. So we've already talked about statistics a little bit, and so we need to know a little bit more about probability in order for us to bring the two together to bring it to the ultimate conclusion of what this whole section of your IB class is about. So first we just need to talk about like just basics. What is probability? To start off, let's talk about how we make a sample space. A sample space is the set of all possible outcomes. All possible, meaning not necessarily the thing that we're trying to study here, right? So like flip a coin twice and record the results. So the sample space here is all of the possible results that you could get from flipping a coin. It isn't necessarily, sorry, my coffee is brewing. It isn't necessarily like if we were looking for what's the probability that you would flip heads both times, right? It's just like what are all the different versions that could happen. I like to actually start this in table form, and at any point, if I'm asked to put it in list form or the tree diagram, I like doing table form first. I'm going to actually do B first. So for flip 1, and then flip 2. For flip 1, we could have heads, and then for flip 2, we could also have heads, right? So for the first flip, it could come up heads, and then for the second flip, it could come up heads. Or the first flip could be heads, and the second flip could be tails. Or the first flip could be tails, and the second flip could be heads. Or the first flip could be tails, and the second flip could be tails. Those are all the different possible outcomes that could occur when we're flipping two coins. This tends to be the easiest subset or the easiest sample space to make because there's not very many options. Let's take this version and right now just put it in list form. So in list form for your sample space, it is a set. And so in order to talk about sets, we need to use our curly brackets. A lot of times in probability, they let the sample space be equal to U. Why? I don't know, but that's why, or that's what it is. So curly bracket, making this into a list, we have the version of, we have the option of doing heads and then heads, heads and then tails, tails and then heads, and then tails and then tails. And so that's how you would take this idea of what we've done in this first table. And that's how we would take this first table and convert it into list form. Another way to represent a sample space is a tree diagram. Hopefully you have seen tree diagrams before, but if not, it's this idea of having one process and then a second process, right? So for flipping a coin twice, we first flip a coin and then we flip another coin. So a tree diagram can only be used if there's steps, like first we did this and then we did that. So maybe write some sort of note to yourself of only step process, if that makes sense. Okay, so we have the first flip, flip 1, and we have two options of what could happen. It could either come up heads or it could come up tails. Sometimes with tree diagrams, we also put probabilities in here. The probability is 0.5 or a half, right? The probability is that it's one of two options, so it's a 50% probability. Then for flip 2, if you flipped heads, you could still flip heads or tails. Same with flip 2, you could either, or down here, if you flipped tails, you could then flip heads and then tails. The result then is that if we ended up on this part of this tree diagram, the result is then heads, heads. If we ended up here in this tree diagram, it ended up that we did heads and then tails. If we did this part of the tree diagram, ending up over here, it means that we did tails and then heads, and then tails and then tails. So then that's right there a way to represent in a tree diagram what the sample space could be, all the different options that are available to us. So a few more definitions here. Determine the experiment, the trials, the outcome, and the event. So lots of definitions here. So I'm sorry, but you're going to have to write small. So the experiment. The experiment is the process by which an observation or a measurement is obtained. So we all know what an experiment means. This is the technical definition. In this case, for the flipping of the coin, the experiment is flipping a coin, right? So that's kind of just, it's the overarching, like, what are we doing? We're flipping a coin. Versus the trial. The trial is a single attempt of the experiment. In this case, the trial would be each flip. So each flip is a trial in and of itself. Trial 1 and trial 2 would be flip 1 and flip 2. The outcome is the result of a trial. So typically only one result, if there's like a sequence of trials that we do to represent the entire experiment, it's just one particular result. So just one head coming up or one tail coming up in the flipping of our coins. So either heads or tails. So the outcome you could represent as a set. That's the worst curly bracket I've ever done. It's either heads, comma, separating the elements in the set, or tails. So those could be the possible outcomes. An event is an outcome or a set of outcomes. For instance, the event in this case is the event of heads, heads, or heads, tails, or tails, heads, or tails, tails. So it's the set of all possible outcomes. So let's go ahead and use this in example 2. It says, when rolling a standard 6-sided dice, what are the sets of event A and event B? Event A is observing an odd number, and event B is observing a number less than 5. A 6-sided die, right? So the numbers are 1, 2, 3, 4, 5, 6. What are the possibilities of observing an odd number? In that case, it would be when we rolled a 1, a 3, or a 5. So the event is the listing of all of the possible things that could result in this. So observing an odd number. We have to stop at 5 because we don't have 7 on a 6-sided dice. Versus B, which is the set of all possibilities of observing a number less than 5. So that would be 1, 2, 3, and then 4. So those are all the possible outcomes that we could get when we're rolling a die and we want less than 5. We're going to flip a coin 3 times and record the results. Show the observing exactly 2 heads as a Venn diagram and as a table. I'm going to first do a table, as I mentioned earlier, to try and just like list out all the possibilities because we need to show all the possibilities of what could happen in order to figure out what are the possibilities for observing exactly 2 heads when we flip 3 coins. So first we're going to do a table, flip 1, flip 2, and flip 3. So it could be possible that we do heads, heads, and heads. It's possible we could flip heads all 3 times. Or it could be heads, heads, and then tails. Or it could be heads, tails, and then heads. Or it could be heads, tails, and then tails. Here I'm accounting for all different possibilities of outcomes. All three could be heads, one of them could be a tail here, or one of them could be a tail here, or both of them could be tails. I like to kind of isolate my first option here and then play around with the resulting options when I've got three or more. It can be a little bit complicated, especially when we get to be more than three. So then that's not it. We still have all of our tails options, which I'm going to squeeze in here. I'm terrible at spacing this morning. Okay, so tails, we could have all three turn tails. We could have one tail, a second tail, and then a head. Or we could have a tail and then a head and then a tail. Or I'm going to write it under here. We could have a tail and then a head and then a head. So that's a total of 8 different possibilities represented in a table. Now, which one of those show observing exactly 2 heads show up? So this one is 3, so we can't count it because it needs to be exactly 2, not at least 2. This one has 2 heads showing up, so I'm going to star it or indicate it in some way of showing that this is the event that we're looking for. The next one is also a possibility of the event that we're looking for. We could do a head and then a tail and then a head. And then we have one more, which is down here at the bottom, where we have a tail and then a head and then a head. So there's 3 different possibilities, but in order to show these events and show these outcomes, you need to show all of the other possibilities with the one that we're looking for. Because we want to know what is this in relation to all of the different possibilities, right? So you're seeing here that's not even like half of the possibilities. You can have already some sort of awareness of what would the probability be when you show all of the possible outcomes and then label which of the possible outcomes are the ones that we're looking for.